All right, guys, I need you guys to open up to a new page in your science notebooks, and I want you guys to write the date of 2/19. 2014. Okay. Over the last few days, we've been talking about solids, and we've been talking about liquids. Who can tell me a property of solids? Ben.
Like, property of solids could be like a flat piece of metal.
A flat piece of metal. So you're saying maybe the shape of something? Guys, I'm going to point out the properties of solids and properties of liquids. Start over here for your help. Okay, Nishan, what is the property of a solid?
Color, shape.
Okay, thank you. What's another property of solids? Merritt.
Do you need hardness?
No, we don't have to write anything down.
Hardness is magnetic.
Hardness, and if it's magnetic. Jalea, what's another property of solids?
Slide it float.
Yes, if it slides or if it floats. Troy, what's another?
Roll stack.
Roll, stack, okay. What are some properties of liquids? London Z.
Water and
That's an example of a liquid, but what's a property of a liquid?
a property is float and see.
That's for a solid. Can someone help him out with the liquids, Miss Alondra? That's an example of it. What is a property of a liquid, though?
Oh.
Grace.
Viscous and fluid.
Yes, if the liquid is viscous or if it's fluid. Can somebody tell me what viscous means? What is that? What is that liquid? Marlon.
Did you say what that liquid?
If the liquid is more viscous than water, is it thicker than water or is it less thick than water?
Thicker.
Thicker. So I need some examples of viscous. Rima.
A milkshake.
A milkshake, yeah, because when you turn that straw, sometimes you have to turn hard.
Yeah.
All right, Kenley, what's another one?
Glue.
Glue. Glue is more viscous than water, definitely. London T.
Shampoo.
Shampoo, yeah. Yesterday when we were playing with the shampoo,
Oh, you're right.
that was like clumpy almost. It was clumpy. Merritt, what's another more viscous than water?
Oil.
Oil, if we tested it out, I bet you it would be a little bit more, it might be on the same level as water.
Wait.
What's more thicker than water? How about ketchup?
Mustard.
Yeah.
Mustard.
Yeah, all those liquids are thicker than water.
They're all sauce.
Sauce, yeah, they're sauces. What's thicker than water? Kayla. Glue is thicker than water. Marlon.
The cream in the milkshake.
The cream in the milkshake. That is right. Yeah, because when you pour cream, it's got a thickness to it. Mishan.
Ice cream.
Ice cream. Okay, that's a tricky one though. If we're talking about melted ice cream, that is thicker than water. But when you pour this is a good segue. If you pour your ice cream into a bowl, when you first get it out, is that a solid?
Yes.
Does it stay the same shape?
If it melts, it is really good. Yeah. It might just kind of splash. I like it.
Okay, but if it's been in the freezer all day and you just pulled it out and you made a scoop, have you ever tried to scoop ice cream and it's so hard
Yeah.
and you put it into the bowl? Does it stay the same shape usually?
Yes.
Yes. So if something stays the same shape, what is it?
I mean, like nature.
Marlon, if it stays the same shape, what is it?
It's
Is it a solid or a liquid?
liquid.
if it stays the same shape?
Solid.
Solid. Okay. All right. Let's talk about this. All right. We're gonna pretend that this is a piece of ice.
What?
Okay. So let's pretend that this is an ice cube. Okay. Would you guys say that this looks like an ice cube?
Yeah.
Yeah. Okay. And this is water.
Yeah.
Do you guys see that?
Yeah.
All right. Here, I'll turn off the light real quick so we can see. Okay. Do you guys see it now?
Yeah. I'm thirsty.
Okay. All right, I'm coming up to the front. All right, so we have our ice cube. This is ice cube, and this is water, and this water is in a cup. If I poured it, would it stay the same shape? No. No, if I poured water onto the floor, remember when I poured the drop of water onto your wax paper? Did it stay the same shape?
No.
It slid all over, slid everywhere. If I took this ice cube and I put it on the same piece of wax paper that we put the water on, would it stay in the same spot usually? Yeah, it's flat. It's flat on all sides.
It's a cube. It might melt. It might melt.
Okay, we're going to talk about melting now in a minute. Do you guys see that ice cubes, what are they made of? Can somebody raise their hand and tell me what they're made of? Ben.
Ice.
Okay, they're ice, but what are they made of? What do we freeze to make ice? Merritt? Water. So do you see how these things are the same thing, but they're not the same thing? This is the solid form of water, and this is the liquid form of water. Do you guys see how there's a difference in it? A solid is stays the shape no matter what. Unless you do something to it. Unless I freeze it, if I melt it, if I take a jackhammer to it like this, then it'll change shape. But if I'm just putting it on a piece of paper, a solid's going to stay the same shape. Okay, do you see how that? If I poured the water under a piece of paper, will it stay the same shape? No, so the water is a liquid. Okay, ice is a
Solid.
very good.
And a liquid.
No. Ice. We're not melting ice. It just came out of the freezer. Ice is a
Liquid.
Solid. All right, everybody with me say ice is a solid.
Solid.
Okay. Water is a liquid. Okay, ice is a solid because it doesn't change shape.
Ice is solid because it doesn't change shape.
Water is a liquid because it changes shape.
Water is a liquid because it changes shape.
All right, so now I'm gonna draw some stuff up here. All right, so if I'm comparing and contrasting, I'm gonna draw this Venn diagram. This is what I want you guys to draw in your books. We are comparing and contrasting a solid and a liquid. This is a solid, ice. And this is a liquid, water. Okay. I'm going to make this bigger because they have a lot of similarities. Alright, can somebody tell me a similarity between these two? Kenley. Yes, you draw the Venn diagram.
Solid, never takes shape.
No. What's the similarity? What is the same about this ice and the water? What is the same about it? I'll give you guys a hint. What's the color? Are they both the same color almost?
Yes.
Alright, what color are they?
Clear. Crystal clear.
Alright, clear. So I'm going to write clear in there. Clear color. Everybody write that.
Clear color.
Do you see how that it's the same, and that's why it would fit in the middle of our Venn diagram?
Yeah. Miss Russell,
Yes.
is this our take it out?
No, because we're gonna do something else. This is not your exit ticket. But I want you guys to write it down. Yes. Okay. Would you say they're both made of the same thing?
Yes.
No.
Yes.
All right. Somebody tell me why yes. Why?
Because
Right.
like the ice cube was water, it's just frozen water.
Yes. So they're both made of water.
I can't write that.
Made of water. Okay. What's different about these two? Can somebody tell me what's different about these two? Merritt.
That one is a solid and that one is a liquid, including that one.
Okay, so the water is a liquid and the ice is a solid. Okay? What about their shape? Does one change and one not change? Okay, what shape, between the ice and the water, who changes shape?
The liquid.
The liquid, so, alright, Mary, I need you to raise your hand. Okay, which one is everybody writing this in their books?
Yep. Oh, yep. Solid.
Okay,
The ice cube is
which one changes shape? Water or ice?
water.
Alright, we're gonna raise our hands and we're not gonna call out anymore, okay? Alright, so the water changes shape. Write that down in your Venn diagram. We're comparing and contrasting a solid and a liquid. This is going to help you because we're going to do this awesome project. Alright, Rima. What? Yeah, you can sit there. Okay. Alright. Does the solid change shape if I just put it on a piece of paper? No. Does not change shape. All right, let's look at some of these properties over here in our properties of solids and properties of liquids board that we've been working on for the last couple weeks. All right, so we talked about the color, we talked about the shape. This ice cube, does it roll? No. Does the ice cube stack?
Yes.
Let's write that in there, because it definitely stacks. What's the next thing that I would look at? Does the ice cube, is it hard?
Yes.
Thumbs up if you think the ice cube is hard. Alright, that's enough to put. Stacks, it's hard. Hard. Okay, here's a tricky. Do you think the ice cube sinks or floats?
It says neither stuff floats and sinks on it. In it.
Or does it do both?
Kind of both. Sink.
Alright.
Sinks and dips.
It's not big enough. I tried to see if that was big enough. But this is not really ice, so that won't really. Ice, it floats at the top. Like if you're drinking some lemonade
Yes.
and you only have 2 ice cubes in the glass, and there's lemonade in the glass, where are the ice cubes usually? Are they at the top? Top. So ice floats.
Yeah.
Anytime, yeah, ice floats.
That's what it is.
Okay, would you say, okay, we've talked about things, is ice magnetic?
No.
No.
Oh, water.
I don't know if I'd want to drink some magnetic water.
Ew.
Or eat magnetic. Oh, there. Yeah, magnetic. Okay.
Both not magnetic.
Yeah, both of them are not magnetic. Okay, not magnetic. Not magnetic.
Oh, yeah.
What's your?
You have to erase this.
No, don't worry about it. Okay, so not magnetic. All right, so now let's talk about this liquid, the water. Water. Would you say it's viscous or fluid? Raise your hand and tell me why. Tori.
Fluid because it comes out fast and it's not like
Yeah, fluid means it moves quickly. When we were dumping the water yesterday, look, when I dump water, it comes out quickly, doesn't it?
Yeah. Bam!
See, when I dump water, it comes out quickly.
Are you gonna try to put it in that water?
No, I'm not gonna try to put it in there. Okay. All right. Do you see how I compared and contrast these solids? If I asked you the question, water is a liquid because, could you guys say it's because it changes shape and it's fluid?
Yeah.
Does that make sense?
Yeah.
Okay. We are going to do this cool project. Okay, since we talked about water and ice today, here, can somebody turn the lights on for me? All right. I need you guys to sit crisscross applesauce in the front because I'm going to read you guys this awesome book.
What? Awesome book?
You guys can close your notebooks. Okay. Okay, so you know how we talked about... Okay, shh. We got our listening ears on, right?
Yep. Yes, but I need to
Crisscross applesauce, shut your science notebooks. Kenley, Jasmine, shut your science notebooks, please. Everyone shut your science notebook. London T, can you shut your science notebook? Everyone sit on your bottom, crisscross applesauce so our friends can see the book. Okay, so we're talking about Merritt. Here, can you please give her bracelet back? Thank you. Okay. We were talking about solids and liquids, right?
Yes, ma'am. Yeah.
Yes, we are. All right. What would you say a snowman is? Is a snowman a solid or a liquid? When you first build a snowman.
It's a solid.
All right, raise your hand if you think he's a solid.
It's kind of both.
When you build okay, when I'm building the snowman, and am I stacking the balls?
Yeah.
Does liquid stack?
No. Yes.
So what is a snowman? Is he solid or liquid?
Solid.
Can I roll his balls, the balls of the snowman down the hill?
Yes.
Yeah. When I'm building a snowman, I roll him and I can make sure that I can get a bigger snowball. So he can roll, he can stack. So is a snowman a solid?
Yes.
Okay. What happens to your snowman after a couple of days?
Turns to liquid.
All right. Who thinks the snowman becomes liquid? Yeah. If you built a snowman in a bathtub outside, before it gets absorbed in the grass. But if you built a snowman in a bathtub outside, and you went out 4 days later, like this is 4 days after the snow is gone, and we're not wearing coats outside. If that snowman was outside, do you think he'd be melted all over the playground? Yeah. If I built a snowman on the top of the playground slide, do you think that he would have turned into a liquid and melted down the slide?
Yes.
All right, so we're gonna read this book about yes, Grace.
I have another example of like a solid liquid.
What is that example?
Like eggs, like when you scramble eggs, like when you crack them, they are.
So they're a solid in the shell, and then when you crack them, they become a liquid.
Yeah.
Yeah, that could be.
I know that because this morning.
And you were thinking about that. That's good. I want you guys to do that when you're at home. Think about what is a solid and what is a liquid. Yes.
Last time when I built a snowman, my snowman stayed for like 7 days.
That is awesome because it's probably really cold outside. All right, so I'm going to read book about snowmen at night. And what do you guys think the book is going to be about? Who has not read the book knows what the book's going to be about? If you've never read this book and just looking at the cover. Okay, if you've read it before, don't raise your hand because I don't want you to ruin the book for people. But what do you think the book is about snowmen at night? Merritt? So you think maybe he's going to melt at night? Troy?
I think the snowmen play at night, and then in the day, they just sit there.
Yeah, and that's what I got from the cover. Up at the top, all the snowmen are sitting still, and down here they're dancing and having a good time. Okay, I'm going to start reading the book. We're not going to go over what we do in reading class. We'll ask you a few questions about it, but we're not going to go really into depth about it. But okay, it's called Snowman at Night. It is by Carolyn Bueller, and the pictures are by Mark Bueller.
They're sisters and brothers?
They're husband and wife. Carolyn is the wife, and she wrote the book, and the husband drew the book. Okay, so let me read the book. All right. One wintry day, I made a snowman, very round and tall. The next day when I saw him, he wasn't the same at all. His hat had slipped, his arms had drooped down. He really looked a fright. It made me start to wonder, what do snowmen do at night? Yeah, he built the snowman, and then the next day he looks all droopy. What happened to him? All right, hold on. I think that snowmen start to slide when it gets really dark. So he thinks they start to slide. Off the lawn and down the street, right into the park. So they slide down the front yards and go down to the park. They gather in a circle while they wait for all the others, sipping cups of ice-cold cocoa made by snowmen mothers. So they're meeting their moms in the park and drinking ice-cold cocoa.
Ice cold.
Ice cold, because if they drink hot cocoa, they would melt. Yeah, their tummies would melt, yeah. Then the snowman games begin. They line up in their places, each one anxious for his turn in the snowman races. Look at them. They're doing some races. They're all anxious. They all really want to race.
Why is that one fall?
Maybe he tripped and fell. Have you ever tripped and fallen?
He's jumping. Maybe he's jumping. I didn't see it.
Okay. After everyone has had a chance at racing once or twice, they go over to the pond to do skating tricks on ice. So all the snowmen, they go over to a pond and they go ice skating. Do you think if you're doing all this stuff, your clothes are getting a little crazy? All right, sometimes they start giggling and then they act like clowns. They bump into each other till they all fall down. So all of them are on the ground. All the snowmen are on the ground. Some are making snow angels.
Snowman angels.
Yeah. Snowman angels. All right. They gather up their snowballs. The pitcher takes his aim, and underneath the moonlit sky, they play a baseball game. These guys are busy. Okay. No one knows just how it started, but soon it's quite a sight with snowmen throwing snowballs in the world's best snowball fight. Snowmen throwing snowballs. You guys ever seen that? I have. Okay. Guys. All right. Can I start reading the next page? Shh. I need to start reading the next page. Okay. Then it's time for sledding. It's a wild ride down the hill. Look at all the snowmen. They're all going down the hill.
Oh my God. Where's the one side that?
Okay. Wahoo! They yell. This is by far the biggest snowman thrill. So they're all sledding. You guys ever gone sledding? Yeah. Just shake your head. Yeah. Yeah. You've gone sledding. I bet y'all went sledding last week when we were off.
Yeah.
guys, our voices are off so we can read the book. Okay. Finally, they're tuckered out and getting sleepy. So they slowly gather up their things and one by one they go. Okay, so if your snowman's grin is crooked or he's lost a little height, you'll know he's just been doing what snowmen do at night. Yeah, that's it. So see how this guy is kind of... Okay, so do snowmen really do that at night?
I wish.
All right, why do you think the snowman looks kind of like this? What happens to the snowman? Rima. He melts. And when ice melts, it becomes a liquid. Okay. So, we're going to do this thing that we're going to hang up on the bulletin board out there about snowmen. And it's called, What's the Matter, Mr. Snowman? We are going to write a letter to Mr. a melted snowman who's a liquid. Do you guys see my pictures down here at the bottom?
No. Can we color it? Solid.
All right, well, we'll talk about that. We're writing a letter to the melted snowman, and we're going to tell him what happened to him. We're going to say that he once was a solid, and we're going to use our vocabulary words over here, okay? So do you guys want to hear the letter that I wrote, Mr. Snowman?
Yes.
All right. So it says, Dear Mr. Snowman, you used to be a solid. Do you think you used to be a solid?
Yeah.
Yeah. Your color was white. Your body was stacked together, and you were hard. He was hard. When I packed him tight and made him nice, he was hard. Then you started to melt. As you were melting, you became a liquid. You were viscous when you first started melting because you were like a Slurpee. Do you think that he's a Slurpee or like a milkshake? You know how when snow melts, it becomes a slushy?
Like a slushy from Sonic.
Okay, so at first he was a viscous liquid. He was thick. He was thicker than water. Then you turned into water under the hot sun and became fluid. And then I said, Don't be sad, Mr. Snowman. I will see you again the next big snow. Sincerely, Mrs. Russell. So I want you guys to write a letter to a melted snowman and tell him that he used to be solid and tell me why he used to be solid using these words up here. Okay? And then I want you to say, then you became liquid. And I want you to use the words over here. You need to use at least 3 words from each column. Okay? Column. So properties of solids column and the properties of liquids column. I want you to use 3 of those 3 words from each column on your letter. And I want you to write your letter on a piece of notebook paper first. And after I read your letter and I think it's awesome and you revised it, we're not writing long letters because the snowman's not that big, is he? Yeah. We're not writing pages and pages and pages. But we are writing just enough to say that once you were a solid, and give me 3 reasons why he was a solid. And now tell me why he's a liquid. Okay? And then you guys get to color him. I'll give you guys the big sheet of the snowman and you guys can color him. But I want you to make him sad because a melting snowman's pretty sad because he's no longer having any fun, is he? So make him sad. And then I'm going to give you each these little squares down here and I want you to write which one's the solid and which one's the liquid, okay? Everyone understand those instructions? Is that pretty easy? Alright, I'm going to dismiss you guys by rows to your desks. And you guys can work on that for the next 5 minutes. But tomorrow we're going to work on, you guys can write a little bit more tomorrow, okay? You can do it for writing too in your, it gives you an idea what to write in your free writing during Daily 5, okay? Okay, I'm dismissing you guys by rows that are quiet. I need rows sitting crisscross, applesauce to the front. When I dismiss you to your desks, you're going to put, actually you're going to take your science notebooks to your desk. You're taking your science notebooks to your desk and you're writing your letter to Mr. Snowman in your science notebook. Okay? Everyone understand? Thumbs up if you understood and you were listening to me. Thumbs up if you were listening to me. You're writing your letter to the sad Mr. Snowman and telling him he was a solid and then he became a liquid, right? Alright. I'm dismissing you guys by rows to your desks to write for 5 minutes. Yeah.
Why do you have to write on a notebook? Do we write on notebook paper?
You can write it in there and then we're going to transfer it to our snowman. Okay? So I don't want to waste a bunch of loose leaf paper if you guys have science notebooks. This is science. Alright, yes, Troy? Okay, let's keep our hands to ourselves, okay? Alright, second row, you guys look awesome. You guys can go back to your desk and you can write for 5 minutes about the snowman. You're writing the letter to Dear Mr. Snowman. If you want to make your snowman a lady, you can make it Dear Mrs. Snowman. If you want to make it a kid, Dear Snow Kid. You guys can get creative with it, okay? Yeah. Snow teenager. You can write whoever, but it has to be a snowman. A snow person. All right, first row, you guys can go and you watch that one. All right, third and fourth row is awesome. Third row, you still need to sit down. Third row, sit down. You guys need to learn sit crisscross applesauce. Yeah.
Sit down.
All right, third row, you guys can go right. Okay, guys, our voices are off. What? Alright, go put it away. London, alright. Voices are off. We're sitting at our desks and we're writing silently.
Did you break it? Mostly, but no.
I'm going to write up on the board the letter. You need to tell the... Alright. My board is not. Yeah, when you guys are done with your story, you can get the snowman to start putting him together so we can put him outside the door.
Hey, Jay.
Okay. Alright, letter to Mr. Snowman, yes.
There's no woman or something.
Yeah, I wrote it up there. If you guys are having a hard time writing Mr., I wrote it up on this board, okay? Letter to Mr. Snowman. Ladies and gentlemen, our voices are off so I can talk without talking over you guys, okay? No talking. Voices are off. I'm going to give you guys, I need you to write, explain how he used to be solid. Explain
That's a boy.
why he's now
It's solid.
a liquid.
Oh, yeah.
And no, you don't have to tell him. This is just what you need to be doing. I need 3 reasons for each of these.
Uh-oh.
Okay, and then I want you to tell Mr. Snowman that everything's going to be okay.
Alright.
Any way you want to know, any way you want to. Tell Mr. Snowman everything's going to be okay. No, you're writing a letter to Mr. Snowman and you're going to explain.
Oh, teenager.
Yeah. Yeah. Some people were asking how to spell Mrs. M-R-S period.
Or M-S.
Or M-S. If your snowman's not married and it's a girl, she's a M-I-S-S. Miss. Reasons. Yes. M-R-S period.
I think it's mine. Do we have to use like?
Yeah, and you're using, remember we're using our properties of solids and properties of liquid. Yes.
Oh, Miss Rosie. I'm not feeling it. I put it on.
Okay, very good. Thank you.
It's a snort girl.